Hello everyone, it's me, Dr. Nidin Divakran, PhD in Material Physics and Chemistry from Chinese Academy of Science, China, under the honorable guidance of Professor Dr. Lixin Wu. Currently, I am working as a research associate at Central Institute of Petrochemical Technology, CPET, Bhubaneswar. My research area is focused on polymer nanocomposites using additive manufacturing techniques to develop sensors, actuators, and triboelectric nanogenerators. So let me give you a brief overview about my PhD thesis work. So every research which we do should have some kind of motivation, right? My motivation was to implement my research in commercial application because there arises an urge in the field of automotive and aircraft industries to develop the polymers having high performance. So this has shifted the focus to develop the polymers with significant thermal, mechanical, and electrical properties. So this was also my aim in my research. The other parameter which I included was to develop the polymer composites with lightweight and high degree of strength. Now, if we are aiming for commercial application, the important parameter is to develop the cost-effective nanocomposite, and mine was also the same, with ultra-low addition of nanofillers. And this polymer composite must have high thermal conductivity for thermal interface material application. So in a nutshell, my research was to optimize the polymerization techniques to develop the polymer nanocomposites. And this nanocomposite was developed by reinforcing one-dimensional, two-dimensional, and three-dimensional nanofillers and try to evaluate and optimize the mechanical, thermal, and electrical properties. The other research which I done in my PhD work was to develop the ultraviolet curable environmental friendly polymer for 3D printing applications. The polymer which I used in my research is unsaturated polyester because of its versatility. The nanofiller which I used initially in my research was graphene oxide. Graphene oxide was synthesized in my lab using the modified Hummer's process, and this graphene oxide was modified using the different functionalization agent to obtain the functionalized graphene oxide. And this graphene oxide, that is functionalized graphene oxide, along with other monomers, were added into the polymer using the in situ polymerization technique to develop the polymer nanocomposite. And guess what we got? For only 0.08% addition of functionalized graphene oxide into the polymer, the tensile strength was increased by 75.2%. That is incredible. And if we are adding just 0.1% of functionalized graphene oxide, we got 53.8% enhancement of storage modulus, and the thermal decomposition temperature at 10% weight loss was increased by 70.3 degrees Celsius. While the electrical conductivity was also enhanced by 10 raised to 9 Siemens per meter. This shows the proper reinforcement and the interaction of the nanofiller with the polymer. Now the other research was focused on the recent exploitation of the environment has created concerns due to the use of petroleum-based monomers. Particularly in my research, I used petroleum-based monomers to develop unsaturated polyester. So my aim was to replace these petroleum-based monomers with bio-friendly monomers and to develop the UV curable unsaturated polyester resins which could be used in stereolithography 3D printer to develop the composites. The other research was to use the digital light processing, that is DLP 3D printer, to make the wearable sensors. And these wearable sensors could be used to detect the human motions and analyze the output in a real-time analysis. So, in a nutshell, my research was primarily focused on developing the polymer nanocomposites, optimizing the polymerization technique, using the 3D printing technique to develop the polymer for commercial application. Thank you so much.